Hello everyone. So this is third part of the solution of miscellaneous exercise of chapter integrals. In this part we are going to solve question number 21 to 30. So let us start with the 21st question. Integrate the following functions. So first one is 2 plus sine 2x divided by 1 plus cos 2x e power x. So this we are going to convert in the form using trigonometric identities, so that we will be splitting first 2 by 1 plus cos 2x plus sine 2x divided by 1 plus cos 2x dx. So that is equal to integral e power x 2 into 1 by 1 plus cos 2x is 2 cos square x plus sin 2x is 2 sin x cos x, then again 1 plus cos 2x is 2 cos square x dx. So now further simplifying, this will become e power x 1, 2 and 2 will get cancelled. 1 by cos square x is secant square x, and plus this will simplify to tan x dx. So if you observe, this is of the form integral e power x f of x plus f dash of x dx. So this will become e power x f of x plus c. So that means here derivative of tan x is f of x, derivative of tan x is secant square x. So it is in that particular form only. So according to this particular property, the answer will come as e power x tan x plus c. So that will be the answer to this particular problem. Now we'll be moving to the 22nd problem. X square plus x plus 1 divided by x plus 1 whole square into x plus 2. So as you can see, this is a rational function and it's a proper rational function. So let us use partial fractions. X square plus x plus 1 divided by x plus 1 whole square into x plus 2. So now when we do the partial fraction, x plus 1 whole square is a repeated factor. So that is x plus 1 plus b by x plus 1 whole square plus c by x plus 2. Now further taking LCM and simplifying, it can be written as a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 whole square equal to x square plus x plus 1. So now we'll be finding values of a, b and c. So if x is equals to minus 1 is substituted, so b will come as b equals to 1. B will come as 1. When x is taken as minus 2, c will come as 3. Now comparing coefficients of x square, we can see that a plus c equals to 1. So c equals to 3 means a equals to minus 2. So now if you write the integral a by x plus 1, so that is minus 2 by x plus 1 dx plus b by x plus 1 whole square is 1 by x plus 1 whole square dx plus c by x plus 2. So we are substituting the values. Now if we integrate this, it will become minus 2 log x plus 1. 1 by x square integral is minus 1 by x plus 3 log x plus 2. So this will be the answer to this particular problem. Now moving to the next one. Tan inverse of root of 1 minus x by 1 plus x. So here we'll take this as I, tan inverse of root of 1 minus x by 1 plus x dx integral. So we are putting x is equals to cos 2 theta. X is equals to cos 2 theta, so that dx will become minus 2 sin 2 theta d theta. Now substituting the values here, tan inverse root of 1 minus cos 2 theta by 1 plus cos 2 theta d theta will become minus 2 sin 2 theta d theta. So again that can be simplified as tan inverse of root of 2 sin square theta divided by 2 cos square theta into minus 2 sin 2 theta d theta. So that is integral of tan inverse tan theta minus 2 sin 2 theta d theta. So tan inverse of tan theta is theta, so it will come as minus 2 will taken outside, theta into sin 2 theta d theta. This can be integrated by parts by taking theta as the first function, this as the first function, and sin 2 theta as the second function. So minus 2 first function into integral of second, that is sin 2 theta d theta, minus integral of derivative of first, that is 1, into integral of second, so now that means this will become minus 2 theta into integral of sin 2 theta is minus cos 2 theta by 2 minus derivative integral of sin 2 theta minus cos 2 theta by 2 d theta. Now that means minus 2 is outside, this is minus theta cos 2 theta by 2 plus 1 by 2 integral of sin 2 integral of cos 2 theta, that is sin 2 theta by 2 plus c. So that now further simplifying, this first term will become theta cos 2 theta, then it will become minus 1 by 2 sin 2 theta plus c. Now if we go back to the substitution, we have put cos 2 theta as x, cos 2 theta x is equals to cos 2 theta, so that means 2 theta equals to cos inverse of x, or theta equals to 1 by 2 cos inverse of x. Further, cos 2 theta equals to x means sin 2 theta is root of 1 minus x square. So putting those values here, the final simplified answer will be 1 by 2 cos inverse of x into x minus 1 by 2 root of 1 minus x square plus c. So this will be the answer to this particular problem. Now let us move to the next problem, that is the 24th problem. Root of x square plus 1 log of x square plus 1 minus 2 log x. So if you write this as I, so that I'll write it as root of x square plus 1 by x power 4, and this log of a minus log b form, so it can be simplified as x square plus 1 by x square, because 2 log x is log x square and log a minus log b is log a by b, so it is equal to this one. So now what we are doing is, here x to the power 4 is written as 1 by x cube into 1 by x, and that 1 by x is taken inside the root. X will go inside the root as x square. So log of x square plus 1 by x square dx. So that is 1 integral of 1 by x cube root of, this can be written as 1 plus 1 by x square. Here also log of 1 plus 1 by x square dx. Now we are doing by substitution. The substitution is 1 plus 1 by x square equal to t. So when you differentiate this, minus 2 by x cube dx equal to dt. So that means 1 by x cube dx equal to minus 1 by 2 dt. So this will become integral of 1 by x cube dx will become minus half dt. So minus half is taken outside. Root of 1 plus 1 by x square is t, root t into log t dt. 1 by x cube dx is minus half dt. So now this can be done using by parts, log t as first function, root t as second function. So it will become minus half, then log t first function into integral of root t, that is t to the power 3 by 2 by 3 by 2 minus integral of derivative of log t, that is 1 by t, into integral of root t, that is t to the power 3 by 2 by 3 by 2 dt. So now further simplifying, this will become minus half, it will come as 2 by 3 t to the power 3 by 2 log t minus 2 by 3 t to the power 3 by 2 by t, that will become t to the power half dt. So again integrating the second part, 2 by 3 t to the power 3 by 2 log t minus 2 by 3, it will become t to the power 3 by 2 by 3 by 2 plus c. So that is minus 1 by 2 2 by 3 t to the power 3 by 2 log t minus 4 by 9 t to the power 3 by 2 plus c. So now taking minus half inside, it will become minus 1 by 3 t to the power 3 by 2 log t, then plus 2 by 9 t to the power 3 by 2 plus c. So t to the power 3 by 2 is common, so t to the power 3 by 2, then 2 by 9 minus 1 by 3 log t plus c. So now coming back and substituting t equals to 1 plus 1 by x square. The final answer can be written as 1 plus 1 by x square to the power 3 by 2, 2 by 9 minus 1 by 3 log t plus c. Log t again we can write it as, instead of t here, can be written as log of 1 plus 1 by x square plus c. So this will be the answer to this particular problem. Okay, now we'll move to the next one. Next, from 25th onwards, it's definite integral. So 25th, pi by 2 to pi e power x 1 minus sin x cos x. So here also, first we will be simplifying the terms using uh, properties or trigonometric identities. So e power x, it can be splitted as 1 by 1 minus cos x minus sin x by 1 minus cos x dx. So that is pi by 2 to pi e power x 1 by 1 minus cos x is 2 sin square x by 2 minus 2 sin x by 2 cos x by 2 divided by 2 sin square x by 2 dx. Now on simplification, pi by 2 to pi e power x will become 1 by 2 cosecant square x by 2 minus cot x by 2. Comparing it with integral of e power x f of x f dash plus f dash of x dx. So if you take f of x as minus cot x by 2, then derivative of that, it will be 1 by 2 minus of minus cosecant square x by 2 into 1 by 2, which is same as 1 by 2 cosecant square x by 2. So that means it can be taken as pi by 2 to pi e power x minus cot x by 2, that is f of x, plus f dash of x 1 by 2 cosecant square x by 2 dx. So the answer will be e power x into minus cot x by 2. Now let us apply the limits pi by 2 to pi. So minus can be taken outside. When we apply the upper limit, it is e power pi into cot pi by 2 minus e power pi by 2 into cot pi by 4. So cot pi by 2 is 0, so it will become e power pi into 0 minus e power pi by 2 into 1. So that means the answer is e to the power of pi by 2. Now moving to the next problem, question number 26. 0 to pi by 4 sin x cos power 4x plus sin power 4x. So again it is to be simplified using trigonometric identities. So what is done in the first step is sin x cos x divided by taking cos power 4x common. So it will become 1 plus sin power 4x by cos power 4x. So that will become tan power 4x dx. Now numerator sin x cos x and denominator cos power 4x. So further simplifying, it will become sin x by cos cube x and 1 by 1 plus tan power 4x dx. So sin x by cos cube x, it can be written as 0 to pi by 4 is the limit sin x by cos x, that is tan x, and 1 plus tan power 4x, and there is 1 by cos square x left, that is written as secant square x dx. So that is what is done is sin x by cos cube x, it is sin x by cos x into 1 by cos square x. So that can be written as tan x into secant square x. Now this can be done by the substitution tan square x equal to t. Tan square x, if you take it as t, differentiating 2 tan x secant square x dx equal to dt, or we are having only tan x secant square x, tan x secant square x dx equal to half dt. Now since it is a definite integral, we will change the limits also. So when x is equals to 0, t equals to tan square 0, so that is tan 0 is 0, and when x is equals to pi by 4, t equals to tan square pi by 4, and tan pi by 4 is 1, so it will become 1. So the integral will become 0 to 1. 1 by 2 is there because of there is no 2 tan x here, so that means dt by tan power 4x will become 1 plus t square. So now integrating 1 by 2 tan inverse of t from 0 to 1. So applying the limits, tan inverse of 1 is pi by 4 minus 0. So the answer will come as pi by 8. Now we will move to the next question. 0 to pi by 2 cos square x divided by cos square x plus 4 sin square x. So let I equals to 0 to pi by 2 cos square x divided by cos square x plus 4 sin square x. Sin square x is written as 1 minus cos square x dx. So that means it will become 0 to pi by 2 cos square x divided by 4 minus 3 cos square x. Now we will be writing the numerator in terms of the denominator, so there should be a minus 3 cos square x. So because of that we are dividing and multiplying with minus 3. So this is minus 3 cos square x now. Now we want a 4 also, so add and subtract 4, then divided by the denominator, 4 minus 3 cos square x. So we have written the numerator in terms of the denominator. So minus 1 by 3, 0 to pi by 2. So this is splitted as two integrals, 4 minus 3 cos square x by 4 minus 3 cos square x dx, and the remaining is plus 4 by 3, 0 to pi by 2 dx by 4 minus 3 cos square x. So the first one, it will become minus 1 by 3, 0 to pi by 2 1 dx, and second one 4 by 3, 0 to pi by 2 dx. Now cos square x is taken common here, cos square x is taken common, will become 4 cos square x is outside, so 4 by cos square x, that is 4 secant square x minus 3. Now that can be done as, so now for the first part it is minus 1 by 3 x 0 to pi by 2 plus 4 by 3, and here also 0 to pi by 2, 1 by cos square x can be written as secant square x dx, and 4 into secant square x can be written as 1 plus tan square x minus 3. So the first part, if you apply the limit, it will come as minus pi by 6, lower limit is 0, plus 4 by 3. Now I further again simplifying this, it will become secant square x dx 4 tan square x plus 1 plus 4 tan square x it will become. So now first part is minus pi by 6, then this one we will be rewriting as 2 by 3, 0 to pi by 2, 2 secant square x dx divided by 1 plus 2 tan x the whole square, 2 tan x the whole square. After that we will be evaluating the second integral by the substitution 2 tan x is equals to t, so that 2 secant square x dx will become dt, and as far as the limit when x is equals to 0, t is also 0, and x is equals to pi by 2, that is t will be tan inverse of pi by 2, so it can be written as infinity. So the integral will become minus pi by 6 plus 2 by 3, 0 to infinity dt by 1 plus t square. So now if you integrate that one, it will become minus pi by 6 plus 2 by 3 tan inverse of t from 0 to infinity. So again taking the values, minus pi by 6 plus 2 by 3, tan inverse of infinity is pi by 2, minus tan inverse of 0 is 0. So it will become as minus pi by 6 plus pi by 3. So pi by 3 minus pi by 6. So the answer will come as pi by 6. That is the answer to this problem. Now, now we will move to the next problem, that is 28 problem. Pi by 6 to pi by 3 sin x plus cos x divided by root of sin 2x. So before doing this, here we will be rewriting sin 2x. Sin 2x, the standard formula is 2 sin x cos x. So that we can write it as 1 minus 2 sin x cos x minus of 1 minus 2 sin x cos x. So that is plus 1 also. So when we expand this one, it will become plus 1 minus 1 plus 1, that is 0, then minus of minus, and this bracket we can write it as sin x minus cos x whole square plus 1. So what we are writing sin x minus sin 2x as 1 minus sin x minus cos x whole square. So sin 2x we are writing it as 1 minus sin x minus cos x whole square. Now we will write this in the integrand. Now let I equals to pi by 6 to pi by 3 sin x plus cos x divided by square root of 1 minus sin x minus cos x whole square. Now why we have written in using sin x minus cos x? Now if we take sin x minus cos x as t and differentiate that, cos x plus sin x dx equal to dt. So if you can see the integrand, the sin x plus cos x dx, it is available in the numerator. So for that purpose only we have taken sin 2x in terms of sin x minus cos x. Now if you take now for changing the limits, x is equals to pi by 6, so t will be sin pi by 6 that is 1 by 2 minus root 3 by 2, and when x is equals to pi by 3, it will be t equals to root 3 by 2 minus 1 by 2. So accordingly, if you change the limits, the integrand will become, lower limit is 1 by 2, that is 1 minus root 3 by 2, and upper limit is root 3 minus 1 by 2. Sin x plus cos x, it is dt divided by root of 1 minus t square. So again, if you do the integral here, it will become sin inverse of t. And now applying the limits, upper limit is sin inverse of upper limit is root 3 minus 1 by 2, so it is sin inverse of root 3 minus 1 by 2 minus the lower limit sin inverse of 1 minus root 3 by 2. But sin inverse of minus x equal to, so this can be written as minus of minus sin inverse root 3 minus 1 by 2, because sin inverse of minus x equal to minus sin inverse of x. So that means the answer will come as 2 times sin inverse of root 3 minus 1 by 2. So this is the answer. Now moving to the next problem. Integral 0 to 1 dx by root of 1 plus x minus root of x. So now rationalizing this, so let I equals to 0 to 1 dx by root of 1 plus x minus root x. So it will become 0 to 1 root of 1 plus x plus root x divided by root of 1 plus x minus root x into root of 1 plus x plus root x. Now simplifying the denominator using a plus b into a minus b, it can be written as 0 to 1 root of 1 plus x plus root x, that is the numerator, divided by 1 plus x minus x. So that will come as 1. So eventually it will become root of 1 plus x plus root x dx. So now integrating term by term, it can be written as 1 plus x to the power 3 by 2 divided by 3 by 2 from 0 to 1 minus x to the power 3 by 2 by 3 by 2 from 0 to 1. So now applying the limits, it will come as 2 by 3 into 2 to the power 3 by 2 minus 1 minus 2 by 3 into 1. So further simplifying, it will come as 2 by 3 into 2 to the power 3 by 2. So that is 2 by 3 into 2 root 2. So answer will come as 4 root 2 by 3. Now moving to the 30th problem. Sin x plus cos x divided by 9 plus 16 sin 2x. It is similar to the 28th problem. So again we are writing sin 2x as 1 minus sin x minus cos x whole square, so that we can take sin x minus cos x as t. So now 16 sin 2x is there, 9 also is there, 9 plus, so the whole thing will change to 9 plus 16 into 1 minus sin x minus cos x whole square. So it will come as 25 plus minus 16 into sin x minus cos x whole square. The denominator will become 25 minus 16 sin x minus cos x whole square. So let I equals to 0 to pi by 4 sin x plus cos x divided by 25 minus 16 sin x minus cos x whole square dx. Now taking sin x minus cos x as t, so it will become cos x plus sin x dx equal to dt. So now again changing the limits, when x is equals to 0, sin 0 minus cos 0, that is, so t equals to minus 1 and x equals to pi by 4, sin pi by 4 1 by root 2 minus cos pi by 4 1 by root 2 equal to 0. So t equals to 0. So it will change to minus 1 to 0 dt by 25 minus 16 t square. Now using the formula dx by a square minus x square 1 by equals to 1 by 2a log of a plus x by a minus x. So this can be written as, it is because it is 4t square, so it will 1 by 4 will be coming, then a is 5, so 1 by 10, then log of 5 plus 4t divided by 5 minus 4t, and the limit is from minus 1 to 0. So that is 1 by 40. If we apply the limits, upper limit, it will come as log 5 minus lower limit, if you apply, it will come as log 1 by 9, log 5 by 5 is there, sorry, 5 by 5 minus log 1 by 9. So that means it will come as 1 by 40 log 1 minus log 1 by 9. So that is 1 by 40 log 9. So this will be the answer to this problem. The remaining problems will be done in the next part.